Hello again, and good afternoon. So I have to leave the scarf, it's really cold here. So my name is still Matthias, I'm the CEO and one of the founders of a company called SpaceOptix, which is a Fraunhofer IOF spin-off, and a company that targets to launch tens and hundreds and one day maybe even thousands of optical systems into space. Did the previous presenter took the presenter? Is it there? Clever move, clever move. Okay, so what's the issue? The issue is big data. So we need big data for everything. So human technological megatrends are based on big data, especially artificial intelligence, the Internet of Things, autonomous driving cars. And in addition to our existing terrestrial networks, space will be the main physical channel to enable those megatrends. So it is expected that in the next 10 years there will be many 10,000s of small satellites launched into the lower Earth orbit. And all of them, or most of them, need optical technologies to exchange or transfer data to ground or in between those satellites. So we're really facing with this space commercialization big technical and economical challenges. One is that the number of systems has increased while we have to produce them by a reduced cost. And everything has to be smaller to fit into a CubeSat platform. So we're actually facing a scaling issue. And what does it mean for optical systems? So actually we want to have components with nanometer precision which are produced in serial production and have to live within a space environment. SpaceOptix will help to solve this scaling issue. So we are a provider of high-performance metal optics which offer unique properties for the new space market. Those kind of optics can be produced at low cost and are scalable to high-volume production. You can easily manufacture freeform optics in these metallic materials, which means that optical designers have the freedom to shrink down the system size to lower mass and to lower volume. And at the end, we have a technology that enables you to assemble those systems within hours instead of months for very complicated freeform shapes. So which are now the technology innovations? Since this is an innovation technology, innovation pitch, and metal optics are produced for decades, mainly for the aerospace and defense market, we think that our technology differs mainly in these 4 points. First, we have an atomic material combination, allowing you to increase the operational temperature range. Second, we are very a specialist in doing freeform optical surfaces, being able to manufacture very compact systems very fast. We have technology in metal printing, so doing printing of optics at the end, and we are able to assemble those systems very fast by our plug-and-play system integration technique. So let me go a little bit in detail. What does it mean? So innovation number 1, a thermal material combination. We have a deep knowledge over the last 10 years using a specialized aluminum silicon material in combination with a nickel phosphorus layer to produce such mirrors. This allows us to match the CTE of substrate and the coating over a large temperature range, which reduces bimetallic bending and still can be machined excellently to optical qualities. Innovation number 2, freeform mirror modules. We are able to simultaneously machine various freeform mirrors on the same substrate, which allows us to make very compact system approaches, for example, for TMA telescopes. We even can test them at the same time and have a process chain that allows us to correct those surface errors down to a couple of nanometers. Innovation number 3, additive manufacturing for mirror printing. This is extremely interesting, especially for structural optimized mirrors, making them even more lightweighted and just use the material there where we really need it for the stiffness of the mirror. We are even able, at one of the very first companies to do that, to 3D print this very specialized material approach, which was the first innovation. Innovation number 4, plug-and-play integration. We have a technology that enables us to machine ultra-precise mechanical interfaces at both optics and mechanical parts, so that at the end you just take your optics, put it down to the telescope frame and integrate it within hours. We have a team of 4 people that are facing these challenges, having all the background in the Fraunhofer Institute, 2 engineers and 2 technicians. We're really focusing to do the fabrication and the testing of the systems, and we are also supported by 2 other colleagues adding or helping us with marketing and public relations and also business development. So at SpaceOptix, it's time for launch. Thank you very much for your attention, and I'm happy to take questions and to discuss with you our solutions for optics at our booth D19. Thank you very much.
Any questions? Thank you very much.
Thank you.